Okay, we are in lesson 3.1, the history of life. Feel free to pause the video, write down your learning goal, and then press play when you are ready to continue. Let's begin with our first guiding question. Why should we learn about the history of life? It's very important for us to understand evolution because this explains how life adapts to the many changes that happens. Now, for us humans, the history of life connects to medicine, climate science, and real life problems that we encounter, like diseases and endangered species. We are all a part of this ongoing story of the history of life, and we need to make sure that we are keeping our earth safe so that we as humans could live longer and live healthier lives. So, how do we even know the earth's history? How do we know that the earth is very old? How do we know that there were dinosaurs ever existing? There are fossils, and fossils are the preserved remains or traces of things that was once living. And there's a cool law called law of superposition. So we find fossils within the rock layers, and the younger rocks are towards the top and the older rocks are towards the bottom. So depending on where we find a fossil is when we can do a rough guesstimate of when it existed. So there's some other information that fossils tell us. So fossils, again, provides us with key evidence of evolution and common ancestry. So fossils show us how organisms have evolved, and I've annotated that as the change over time. Being a fossil or being fossilized is very hard to do. There has to be a very specific set of conditions. So it has to be an organism that doesn't have like soft bodies. So having bones are helpful. Shells are very helpful to see something that gets fossilized. It also has to be buried quickly and quickly preserved in sediment. The deeper that we find the fossils, the older that they are. So like I said, because there are a lot of gaps in the fossil record and not everything is able to become a fossil, that there is a lot of incomplete data. So scientists are often just trying to piece together random pieces of the puzzle to understand how life has evolved and changed over time. So how old is the Earth? We know it's old, but let's take a look at this geological timescale and figure out how do we read this. So first, when we see an image, we need to look at the title. This title says geological timescale, 650 million years ago to the present. Then I'm going to hop over to my y-axis. Ooh, what's going on here? This shows me, and I'm leaning over, the millions of years ago. And I see that the oldest number is here, 650 million years ago. And the youngest is over here at 0. So this is kind of reversed from a normal graph that we see. We can see that humans have evolved around 2.5 million years ago, and that the first reptiles has started to become around 325 million years ago. So this is kind of like a calendar and kind of helps you understand how events like extinctions change the course for evolution. So every time you see a color change, that indicates that there was a mass extinction that happened and it created new life forms. What are mass extinctions? Mass extinctions are the sudden loss of many species. Here's an example. Let's say all the humans on this earth die out. RIP to us. That could cause a ripple effect. So then all the dogs die out, all the cats die out, and other things could start dying out. That could start causing a mass extinction. So unfortunately, if we all die, that sucks for us humans. But after each mass extinction, these types of events creates opportunities for new species to evolve. For example, after the dinosaurs went extinct, mammals expanded and evolved, including us humans. I want you to think about though, although it would be a good thing because there will be a new opportunity for life to evolve after us humans die out, we don't want to die out. We want to live. We want to continue as a species and live forever. So every time we lose a species, our human well-being and chance of long-term survival is greatly reduced. Keep in mind, from our Unit 1, we learned that our ecosystem needs the proper balance of certain gases like oxygen and carbon dioxide in the atmosphere to support life on Earth. And the amount of water the pollination of crops, plants growing are all factors that are very delicate that can easily throw off the food chain of life and put us at a chance of non-survival. And finally, we need to think about, what do all living things have in common? And this is a very strong key idea that you need to know for your regions. All living things share a common ancestor. If we go far enough on the timeline of life, we're going to be all linked to a single common ancestor. And yes, I mean all. Every single thing that's alive on this earth, a plant, a banana, a rat, a goat, a bird, we all share at some point or another a common ancestor. And that's all I have for you in this video.